Hello children, in this video we are going to learn about motional EMF from Lorentz force. Right, already you know that about Lorentz force. You have learnt in the third unit. Now we will see what is motional EMF from Lorentz force, right? Refer the diagram. You can see the crosses which represent the magnetic field which is acting perpendicularly inward. In that perpendicular magnetic field, a metal rod AB is placed of length L. Metal rod AB of length is placed in this magnetic field, and it is dragged with velocity v. V is the velocity with which the rod is moving. You know that metal conductor have more number of free electrons, right? They are good conductors of electricity. Free electrons are there, more number of free electrons in this conductor. So these free electrons, if you drag, okay, so there will be the moving charges in the perpendicular magnetic field. It will experience, right? Do you remember children? Magnetic Lorentz force, right? So moving electrons in this perpendicular magnetic field experiences magnetic Lorentz force. Okay, now the direction of the magnetic Lorentz force. Already you know the formula for magnetic Lorentz force. F vector is equal to, this is the general formula, F vector is equal to Q into V cross B, right? Instead of Q, here we are considering electrons, so you can write it as minus E. You should know the direction of this magnetic Lorentz force. It can be determined by right hand thumb rule. So if you apply right hand thumb rule, you can say that the magnetic Lorentz force acts from B to A. That is the reason the electron will be drifted from the end B to the end A. Right? Electron moves from B to A, and the electrons are accumulated at this end A because of the magnetic Lorentz force. Okay children, now as the electrons are accumulated at the end A, it gives rise to the potential difference. More number of, due to Lorentz force, all the electrons are accumulated here, more number of charge here compared to this. So there will be electrical pressure between these two ends which gives rise to the potential difference. Now I told you that using right hand thumb rule, Lorentz force will be acting from B to A. We will see how it is, right? Now you refer the same diagram children. Magnetic field is acting inward and the rod is placed. V is the velocity of the rod. Now this is the general formula for Lorentz force. F is equal to minus E V cross B. You bring the negative sign inside the bracket, so you will get, instead of V cross B, B cross V, right? So that is what I have written here, and you can take this to be the first vector and this is the second vector. So the resultant of these two vector is F vector, Lorentz force, right? Now so B is the first vector, second vector V. So we will try to apply the right hand thumb rule. For that, what will you do? You have to take all these four fingers and you have to place it in the direction of first vector. That is, all the four fingers should be inside the paper, right? You have to place it inside the paper so that the palm should be facing the second vector. So keep it inside, put it in all these four fingers into the paper, and it should be facing the second vector, V vector. If you curl your finger from first vector to the second vector, the direction of the thumb gives the F vector direction, that is the force, okay, Lorentz force direction. You can do it by yourself. Place all the four fingers into the paper, curl towards the second vector, V vector. At that time you can see the thumb pointing downward. So that will be the direction of Lorentz force. That is why Lorentz force is acting from B to A. So electrons are drifted from from the end B to A, right children? You can apply the right hand thumb rule by yourself and check that. Now, so as I told you, electrons move from B to A by the right hand thumb rule because Lorentz force is in that direction. So the electrons, this Lorentz force, electrons are accumulated at the end A, which produces the potential difference. Now we will go to the second part of this answer. For that, what you can say is, now you know that this rod which is having free electrons, it will produce the electric field, right? So the moving charges, free electrons in electric field, it will experience force. Okay, that we call as the Coulomb force. So force on the electron in electric field is given by minus E into E. This you are familiar with this formula, children. You know that E vector is equal to, first unit you have learned this, F vector by Q vector, right? So F is equal to Q into E. The same thing we have written. Instead of Q, I am having the electron minus E, right? So now how long these electrons will be saturated at this NDA, children? Only as long as you drag this rod, at that time only the electrons will be moving from B to N and they will be accumulated, right? So till saturation point the electrons will be moving to NDA. So at equilibrium you can say the Lorentz force and the Coulomb force are equal. Substitute these values. You know from equation 1 you can write this E minus E into V cross B vector. The value of Coulomb force is minus E into E. A cross B is AB sin theta. So VB sin theta, right? You can cancel these minus E and minus E. So you will get theta is how much, children? 90 degree. Theta is 90 degree. That is the angle between V vector and B vector. Both are perpendicular, right? So sin 90 is 1. So you will get VB is equal to E, right? Let it be the third equation. So potential difference between the ends of the rod. Already you have learned from the unit 1. Relationship between the potential and the electric field is dV is equal to E into dx. You have come across such type of expression. The same thing we have written here. So potential V is equal to E into L. L is the length of the conductor, V is the potential, E is the electric field. You try to differentiate between this capital V is the potential and the small v is the velocity of the rod. Okay, so now you can substitute this third equation value here in this fourth equation. You will get potential V is equal to, instead of V you can write it as VB into L. Okay, so V can be replaced as EM of epsilon is equal to VBL. V is equal to EM of epsilon, right? So already you know what is meant by EMF, right? You already have discussed that magnetic Lorentz force gives rise to the potential difference across the ends of the conductor. So we are saying that, you know what is meant by EMF, right? What is EMF? That is nothing but the work is done on the electron. Okay, work is done on electron by the magnetic Lorentz force, right? To drift electrons from end B to A, right, children? So this work done is nothing but we call it work done by the electron, we call it as the EMF. So magnetic Lorentz force gives rise to potential, which in turn gives rise to the EMF of the cell. Okay, EMF I mean. Okay, so magnetic Lorentz, the same thing I have written here, magnetic Lorentz force gives rise to the potential difference, hence the EMF. So why do we call it as the motional EMF? EMF is produced by motion of the rod, hence we call it as the motional EMF, right? Next you are going to find the current. Already you know the current value I is equal to epsilon by R. By Ohm's law, instead of V I am replacing it as epsilon. So R is the resistance of the conductor, epsilon value is VBL. Okay, substituted. So direction of the current is given by the right hand rule. Okay, children, till this you write it is enough, but anyhow you note down this, children. In exam you write till this, it is enough. Okay, so you can note on this also, but you can say that inside the conductor, you can say you are saying electron moves from B to A, right? Conventional current direction is opposite to the direction of electron flow, right? So what will be the current direction? Electron is flowing from B to A. So current will be flowing from A to B. That is the current direction inside the conductor. So current direction is A to B inside the conductor. The same conductor, if you connect it to an external circuit, say micrometer, if what happens, how will be the current flowing? It will be flowing from, you know that because all the electrons have shifted here, this end will become positive. So current will flow from positive to the negative end, B to A, through this micrometer. Inside the conductor current is A to B and outside the conductor it is from B to A. Got it, children? Hope you understood. Thank you.